All right, in this lesson, we are going to apply the properties of logs. There's 3 specific properties we're going to be using, and we're going to use those to condense and expand different logarithmic expressions. So as we're working through, I want you to specifically focus on when expanding a log, where does the exponent go? That's going to be our focus. It's one of the 3 properties we're going to talk about. So let's go ahead and get started. There are 3 properties that we're going to focus on: the product property, the quotient property, and the power property. These are all terms we've heard before. We've used the product property, the quotient property, and the power property when we've dealt with exponents, and that's what we're dealing with today. All right, so let's talk about what the product property actually says. So it says log base b of 2 numbers being multiplied together. So when those 2 numbers are being multiplied together, I can rewrite that log as log base b of m plus log base b of n. So the product property basically says if I see 2 values, 2 logs that are being added together and they have the same base, that is essentially the same as taking the log of that base of those 2 numbers being multiplied together. These properties are going to be really important as you move forward in your math, so in your pre-calc and your calculus classes. So make sure that you're understanding those connections. So when I see something like number 1, where it says log base 2 of 7 plus log base 2 of 4. So one of the things I noticed is that addition is happening. I also noticed that the bases are the same. So I can condense it into a single logarithm, which is my goal, by using the product property. So I can say that log base 2 of 7 times 4 is going to be the same way. So I've condensed it into a single log. So here it was 2 logs, and I was able to use the product property that says addition actually means multiplication when I have the same log and base. And then I just simplify 7 times 4. And so my answer here is log base 2 of 28. Now you may be thinking, okay, why are we doing this? Well, eventually in our lessons later on, we're going to be actually solving. And we need to know these properties really well and be able to move between the 2 formats in order to solve those equations. So what I'd like you to do is pause the video, and I'd like you to try number 2 on your own. So log 25 plus log 4. If you notice, they don't have a base that's explicitly written there, but what do you know about the base that is actually there? So pause the video and try this one on your own. So hopefully you were able to remember that if there is no log written there, it's automatically a 10. And so they both have a log base 10. So I can use the product property to rewrite it as log of 25 times 4, which is the log of 100. All right, let's go on to number 3 and see if we can figure this out. So I'd like you to pause the video and try to rewrite it into the product formula. All right, so hopefully you were able to rewrite it as log base 4 of 2x times 4x squared, which that simplifies into log base 4 of 8x to the third, because I multiply those coefficients and I add those exponents. All right, so now we're going to work ourselves backwards. So we're going to expand using the product property. And I will let you know that the answers may vary on these, so you may come up with a different exact answer as me, but as long as it still works, that's okay. All right, so let's talk about number 4. So I see that it's in log form. It's one single logarithm. So I can use the product property to take that one single log and expand it into 2 logs that are being added together but that still have the same base. So essentially I'm looking for what factors of 6 could I rewrite it as. So I could use 6 and 1, or I could use 3 and 2. It really doesn't matter. So I'm going to choose 6 and 1. So it would be log of 6 plus log of 1, because if I use the product property and work backwards, it would end up being log of 6 times 1, which then simplifies to the log of 6. You could also have the answer log of 2 plus log of 3, or because in multiplication and addition order doesn't matter, it could also be log of 1 plus log of 6, or log of 3 plus log of 2. So that's why the answers may vary, just as long as these 2 numbers multiply to be that value. All right, so go ahead and pause the video, and I'd like you to try number 5 on your own. All right, so for number 5, you could have any of these 3 answers. You could have log base 7 of 1 plus log base 7 of 45, because 1 times 45 is 45. You could also have log base 7 of 3 plus log base 7 of 15, because 3 times 15 is 45, and then the same is true for 9 and 5. So as long as you got one of those combinations, and again, you could have them in a different order, but those same numbers have to be together. All right, let's look at example 6. And this one is a little tricky, but I think we can figure it out. So log base 2 of 5x. So I'm looking for, just like I did over here with 45, what 2 numbers multiply together to give me that 5x? Well, the only way I can see it is 5 times x. So when I expand my log, it would end up being log base 2 of 5 plus log base 2 of x. All right, go ahead and pause the video and take note of any of the answers that you're confused on or you have questions about. All right, so what are you going to need to remember about the product property of logs? So that when you're looking back through your notes, you can see this is your quick summary. This explains everything that you know about the product property of logs right now. All right, so the next property that we're going to talk about is the quotient property. And so the quotient property says that when I have log base b, and they have the same base, of 2 numbers that are being divided, unlike the product property that was talking about 2 numbers being multiplied, I can rewrite that log in an expanded form of log base b of m minus log base b of n. So this quotient property goes both ways. I can take something that's being divided and write it as 2 subtraction logs, or I can take 2 logs that are being subtracted and rewrite them, condense them into 2 logs that are being divided. So the quotient property says that division and subtraction go together. So let's go ahead and look at number 7. It's wanting me to condense it into a single logarithm. So I'm going from an expanded form to a simpler version, and it's asking me to simplify if possible. So if I'm going from subtraction to division, chances are I might have a fraction that needs to be simplified. All right, so we have log base 3 of 24 minus log base 3 of 8. And I notice that it is subtraction, and I have the same bases. So I can rewrite this as log base 3 of 24 over 8 because they're being subtracted. So when I put them together, they will be divided. And I can simplify. 8 goes into 24 3 times. So my final answer is really log base 3 of 3. All right, so I'd like you to pause the video and try number 8 and number 9 on your own. All right, so for number 8 and 9, hopefully you were able to get these answers. If you didn't, then I'd like you to pause the video and write down any questions or identify any places where you're confused about my work or my answers. All right, so now we're going to work backwards. And again, just like we had with the product property, your answers will probably vary from mine. But as long as at the end of the day, when I divide the 2 numbers, I get 4, it doesn't matter what values I use. So I'm going to look at number 10 and I'm going to say, okay, log base 8 of 4, I'm going to expand using the quotient property. So the quotient property says that when I divide 2 numbers, the answer is 4, and I can expand it by taking those 2 numbers that are being divided and subtract them. So the number I came up with was log base 8 of 8 minus log base 8 of 2. So when I think about it, 8 divided by 2 gave me 4, so I was able to rewrite that as log base 8 of those 2 numbers being subtracted. So go ahead and pause the video, and I'd like you to try number 11 and 12 on your own and see if you can just come up what the expanded version is. All right, so for number 11, probably most of you came up with log base 5 of 1 minus log base 5 of 3. You could have also done any sort of multiple that divides to 1/3. So you could have done something like log base 5 minus log base 5, log base 5 of 5 minus log base 5 of 15, or log base 5 of 3 minus log base 5 of 9. Anything that when I take those numbers and put them back together, I get a fraction that reduces to 1/3. And then number 12 was pretty easy. It's a log base 10, so I don't have to write that base in. And it becomes log of m minus the log of 7. So before we move on, make sure that you identify any of these answers that you don't understand, that you want to talk about. Put any notes or questions that you might have. So pause the video if that is the case. All right, so let's come up with a summary for the quotient property. What are you going to need to remember? What are important things that when you're looking back through your notes will cue your memory, maybe examples or just how you would summarize it. All right, so the final property that we're going to deal with logs right now is the power property. So the power property says that log base b of m to the n can be rewritten as n times log base b of m. So essentially what happens is we just take that exponent and we put it down in front of the log base b of m. So this is kind of an easy property in that you just simply have to look for that exponent, if anything's being raised to that power, and simply bring it down in front and multiply it by the log that exists. So let's go ahead and try some problems out. So number 13 says 5 times log base 4 of 2. So it wants me to condense into a single logarithm. So right now it's currently in this state, and I need to put it into the condensed form. So I know that to put it in the expanded form, I simply took that exponent and put it out front. So that means that this 5 is now going to be put back as the exponent of the 2. So my answer to number 13 would be log base 4 of 2 to the 5th. And I can simplify 2 to the 5th as log base 4 of 32, because 2 times 2 times 2 times 2 times 2 is 32. All right, so go ahead and pause the video and see if you can write the remaining 2 problems in condensed form using the power property. All right, so 14, hopefully you were able to get log base 2 of x to the 7th. So that exponent simply comes out, or I'm sorry, that 7 simply comes out and becomes an exponent. Now on 15, I would accept either of these 2 answers. We've talked a little bit about exponents as fractions, and essentially what that means is if it's 8 to the 1/3, the 8 to the first part, so the numerator goes in the square root or the radical sign, and then the denominator tells me what root I'm taking. So in this case, I'm taking the 3rd root of 8. If you didn't put that, that's okay. As long as you got to this part, for the sake of right now what we're doing, we'll work more with radicals later. All right, so the last 3 questions on this is we are going to expand using the power property. So we're going to work backwards essentially. So we're going to rewrite this into its expanded version. So when I look at this, I know that this exponent 7 is simply going to come out in front. So my answer to this is going to be 7 times log base 2 of 8. So go ahead and pause the video. I'm going to have you try 17, and then I'm also going to have you try 18, but let's go ahead and rewrite number 18 together so that it's already in the exponent form. So it's w, the square root of w. So when we talk about up here, it was the 3rd root. So we divided by 3. So this is the square root, and we've only ever really dealt with squares, and so squared means to the 2nd power. And the w is being raised to the 1st power because there's no other exponent there. So I can rewrite this log as log base 7 of w to the 1/2, because that's another way of writing square rooting. So go ahead and pause the video, and I'd like you to expand using the power property. See if you can expand these logs. All right, so for 17 and 18, 17 was a little tricky, but I wanted to see if you remembered your algebra skills. So I'm taking this whole value of x minus 1 and putting it out front. So I put it in parentheses to represent that it meant one number. And if I'm multiplying that by the 3 that already exists out there, then I distribute my 3. And so I have 3x minus 3 as a value that's being multiplied by the log of 4. And for 18, you should have ended up with 1/2 log base 7 of w. All right, so we're going to take a minute and we're going to do a summary about what you need to remember about the power product of logs. So make sure in your notes that this is a clear interaction so that you can go back and reference it when you're studying. Alright, so this should be a handout that you have. I want you to take a minute and I'd like you to pause the video and see if you can fill this out as much as you remember. So what do you remember about the rules, and can you apply it to two different examples? Alright, so hopefully you were able to remember that anytime that I have log base b of that same number, that value is 1. Because I'm thinking b to the what would be b. Well, b to the first power is the only way that it can be itself. And then also hopefully remember anything that is raised to the 0 power is 1. So b to the 0 is 1. So in these two examples, log base 14 of 14 is 1 and log base 3 of 1 is 0. That's just a quick reminder. All right, so the product rule, the quotient rule, and the power rule we just talked about. So when I'm multiplying, I add them when I expand. So over here I took log base 2 of 9 plus log base 2 of 7 because 9 times 7 gives me that log base 2 of 63. And then condensing, we take log base 5 of 6 plus log base 5 of 7. Because they have the same bases, I can put them together by multiplying because addition is the same as multiplying when I condense it, and 6 times 7 is 42. All right, quotient rule is the opposite. Instead of multiplying and adding, I'm dividing and subtracting. So over here, when I expanded, I took 9 and I thought about what number divided by what number would give me 9. I chose 9 and 1. You could have chosen 18 and 2 or 27 and 3 or 90 and 10. It doesn't matter as long as those two values that are here and here divide to be 9. And this is the common log. Down here, there is no base, so it's an understood 10. I could have written 10 in, but I didn't need to. And then condensing, I see log base 4 and log base 4, and subtraction. So that's the same as m minus n, or m divided by n. So 84 divided by 12 gives me 7. So log base 4 of 7. The power rule just says that that exponent comes out in front of the log. So over here, x minus 1 is the exponent. It just comes out in front of the log. Here, to condense it, it goes into the exponent position. So that's 8 to the second, which gives me log base 3 of 64. And then the change of base formula, we're going to use that a lot when we start solving logs. So it just says log base b of a is the same as log of a over log of b. So remember the large number, not the base. The base goes in the bottom, so base. So this example would be log 32 over log of 7 using that common base 10. And we use that so we can type it into our calculator, and we do log of 32, close that parenthesis, divided by log of 7, and I get 1.7810. All right, so we are going to put all of these product, quotient, power properties together, and we're going to be given some expressions that are either condensed and we have to expand them using those properties, or they're going to be expanded and we need to condense them. So here's some guiding questions that I use to think through. First of all, are the bases the same? I cannot apply those properties unless the bases are all the same. Okay, then I think about, is there an exponent to simplify? So either there's an exponent and it needs to come out front if I'm expanding, or there's a number out front and I can put it as the exponent if I'm condensing. Then what operations are present? So I'm looking for, is there addition, is there subtraction, is there multiplication, or is there division? Because then what operation do those connect to? If there's addition, I can turn it into multiplication or vice versa, and subtraction can be division or division can be subtraction. And then can I simplify any numerical values? So if I end up with 8 to the second, instead of leaving it as 8 to the second, I'm going to say 64. So let's go ahead and put these questions to use. All right, so in these first 8 examples, so examples 19 through 26, we're going to be condensing. So we're going to be given the expanded version, and we need to put it as a single logarithm. So let's go through those questions. So the first question, are the bases the same? So when I look at example 19, they're both that common base. So because they're that common base, I can apply these properties. So the second question, is there an exponent to simplify? So in this case, I have the expanded version. I need to condense. So I'm going to ask myself, is there a number out front to make an exponent? So I'm going to look at these as two separate values, and I see I have 2 times log of 6 minus log of 9. So the first expression, 2 times log of 6, does have a number out front. So I'm going to move that back to where it belongs. So I'm going to rewrite this. And I get the log of 6 to the second minus the log of 9. So then my third question is, what operations are present? And I notice that I have subtraction. So what operation does subtraction connect to? It connects to division. So I'm going to rewrite this as the log of 36 over 9. So I got the 36 because I simplified 6 squared. And so I have the log of 36 over 9. And then my last question is, can I simplify the numerical values? So can I simplify 36 over 9? I can. And I just get the log of 4. All right, so let's go ahead and let's look at number 20 together. So we're going to go through that same progression of questions. So the first question is, are the bases the same? And so when I look at them, I see that everything is in base 4. So I see I have base 4 and base 4 of my 2 terms, so I'm okay. Is there an exponent to simplify? So we're condensing, so I'm looking for a number out front. Well, they both do. So this 4 can go to the exponent and the 2 can go to the exponent. So let's rewrite that. So moving that 4 to the exponent and the 2 to the exponent, I get log base 4 of a to the 4th plus log base 4 of b to the 2nd. So then what operations are present? Well, I notice that I have addition. So what does addition connect to? Addition connects to multiplication. So I'm going to rewrite that in one single log using multiplication. And I end up with log base 4 of a to the 4th, b to the 2nd, because I can't combine those any further. Now you may see these with parentheses, just showing that the whole log base 4 is that piece, but this is also a sufficient answer. All right, I'd like you to try 21 on your own. We're going to look at 22 together in just a second, but go ahead and pause the video and try number 21 on your own. All right, so for this one, hopefully you're able to get that condenses to log base 4 of u to the 7th over v to the 6th. Now, I'm going to guess that if you didn't get that, where you have it different is v to the different power. So we already have v to the 2nd, and we're raising it to the 3rd power. So if I have 2 v's 3 times, that's going to end up being v to the 6th. So you need to pay attention. If there's already an exponent, I'm just increasing it to that next, that many times. All right, so we're going to look at 22 together because it's actually got 3 parts. So we're going to have to think through the order of operations, but we're going to go through our same questions. So are the bases the same? So I see that all 3 of them are log base 2, so we can apply these formulas. Is there an exponent to simplify? So I'm condensing, so I'm looking for a number out front. So there are no numbers out front, so we're not going to have anything raised to any powers. What operations are happening? So when I look at it, I have addition, and then I have subtraction. So the order of operations says we do addition and subtraction in the order that we see them. So what we're going to do is we're going to essentially have this value, and then we're going to subtract this value right here. So where I'm going to start is with the addition piece. So what operation do those connect to? So addition is going to connect to multiplication. So I'm actually going to rewrite this as a multiplication problem. So that's the same as log base 2 of 15 times 4 because those are connected by addition, which when I'm condensing becomes multiplication. So now I'm going to take care of this minus. So it's this value minus this value. So when I rewrite that, I'm going to have, So really, it's going to be log base 2 of 15 times 4, and then I'm going to divide it by 6. So we go in that order of operations in order to simplify. So I'm going to do the multiplication first and then the division that comes along with that. But it's this whole value that's being divided. So my last question is, can I simplify any numerical values? Well, these are all numbers, so I can simplify them. So I'm going to do 15 times 4 and then divide that value by 6. Which ends up being log base 2 of 10. Alright, so what I'd like you to do now is, now that we've worked through all the different types of examples, let's see how you can do with condensing using those properties. So use those guiding questions and work through these problems, and let's see how you do. Alright, so for 23, 24, 25, and 26, these are my results. So 23, I got log of 28, log base 3 of 28y. For 24, I got log base 5 of 2. For 25, I got log base 2 of 2. And for 26, I got log 54. So go ahead and pause the video if you got any different answers and look back through my work and see if you can see where we differed. If it makes sense, then go ahead and move on to the next examples. If not, I will explain them now. Alright, so for 23, I went through that same process. So do I have all the same logs? And so they're all log base 3. So my final answer is log base 3. And then do I have any exponents? So this 1/2 is going to go to the 49. So 49 to the 1/2. And I went ahead and simplified that. 1/2 means square root. The 49 is being raised to the first power, and the 2 tells me what type of root. So that's a square root. So the square root of 49 is 7. So then what operation is occurring? I have 3 numbers that are being added. So what does addition connect to it? It connects to multiplication. So I have 4 times y times 7. And then can I simplify any numerical values? 4 times 7 is 28. All right, so for 24, they're all log base 5, so we're good. The 1/3 goes behind, and at the same time I saw that there was addition, so I turned that into multiplication. So I have log base 5 of 8 times 27 to the 1/3 power, that's just all that simplified or condensed, minus log base 5 of 3. Well, 8 times 27 is 216, and I went ahead and saw that this was subtracting. So it's this whole value subtracting this log. So it's that 216 to the 1/3 divided by 3, that whole thing. And so I thought about 1/3. So that's 216 to the first power, and I'm taking the cubed root. So what number times itself 3 times? So what times what times what would give me 216? And I found that that was 6. So I have log base 5 of 6 divided by 3, and 6 divided by 3 is 2. Alright, so for 25, this 3 needed to go out as the exponent of the 4. So they have the same logs. So 4 to the 3rd, and then subtraction is happening, so that's divided by. So 4 to the 3rd is 64, 4 times 4 times 4, and divided by 32, which is 2. Alright, number 26. I had 2 exponents that I needed to simplify. They're all the common logs, so log base 10. So that became 6 to the 2nd minus log 16 to the 1/4 plus log 3. So 6 to the 2nd is 36. 16 to the 1/4 is 16 to the first power, and I'm taking the 4th root of that. So what times what times what times what gives me 16? 2 times 2 times 2 times 2 is 16. So that's simplified to log 2 plus log 3. So I'm going to guess that some of you, if you made a mistake, you simplified this first, but that is not accurate. I am actually, when I have addition and subtraction according to the order of operations, I move left to right. So I'm going to do log 36 minus log 2, which is division, and 36 divided by 2 is 18, plus that log 3, and addition is multiplication. So it's 3 times this value right here, and that gives me 54. Alright, so that was a lot of information. So go ahead and take a moment and have some interactions, write down questions that you have, what makes sense to you, and what do we need to remember when we're condensing logs. So what are the things that you need to look for? What were your steps? What questions do you have? This is where you need to have an interaction with that process. Alright, we're going to move into our final thing for this lesson. I know this is a long one, but hang in there. You'll get time to practice with it tomorrow. So we are now going to expand. So we're going to take logs that are one piece and we're going to break them into multiple pieces. Before we were condensing, so we're taking multiple pieces and making it one single log. So we're going to go through that same process. I'll model the first couple and then you will get some time to try on your own. All right, so number 27, I have log base 6 of x times y times z to the 4th. So the first thing I'm going to do is I'm going to break it apart. So I see that I have multiplication happening. So when I have multiplication happening, I know that that is the same as log base 6 of each of those being added. So I'm going to do that first. All right, so that gives me log base 6 of x plus log base 6 of y plus log base 6 of z to the 4th. So once I've broken it into the different pieces, I need to take care of any exponents. So I'm kind of working through those questions backwards. So I found the operation that was happening, I connected it to its property operation, and now I've got to take care of any exponents. So in this case, I see that there's a 4, I've got to put it out front. All right, so once I bring that out front, my final answer is log base 6 of x plus log base 6 of y plus 4 times log base 6 of z because that exponent came out front. All right, so let's look at 28. So I have log base 4 of this division. So I see division. What does that connect to? So I can rewrite that as subtraction. So I'm going to do that. All right, so that gave me log base 4 of a to the 9th minus log base 4 of b because division means subtraction. And so then I need to make sure I don't have any exponents that I need to clear out, which I do, so that 9 is going to come out front. So that gives me 9 times log base 4 of a minus log base 4 of b. And then I can always check myself and work backwards. So if I moved the 9 to the power of a and subtraction means division, I would end up right back where I started. All right, so let's look at 29 because it's a little bit different. I just want to make sure that you catch on to this little nuance that's slightly different. So when I look at this, I noticed that when I first approached this one looks very similar to this one in that I have some multiplication happening, same over here. These are very similar. However, one difference is that I have no exponent here and I do have an exponent here. So there's a couple of ways we can approach that. I'm going to show you 2 different ways you can solve it, and you choose whichever one makes sense to you that you're not going to lose the details. So first of all, this exponent means this 2 times. So I could essentially rewrite this as log base 7 of q to the 8, because I have 4 q's twice, r to the 4th. So the first method would be to distribute that squared. So since it's all multiplication that's happening inside the parentheses, I can do that. So it means essentially q to the 4th, r to the 2nd 2 times. So then here, now I have a problem that looks just like the one up here, where I see I have multiplication. So I'm going to turn that into addition. So that gives me log base 7 of q to the 8 plus log base 7 of r to the 4th. And then the last thing I need to clear out is those exponents. So this 8 is going to come out front, and this 4 is going to come out front of that second term. All right, and that final answer would be 8 times the log base 7 of q plus 4 log base 7 of r. So there's one way you can approach it, is you can distribute that 2 and then simplify. Or there's another way that I'm not sure why, because this seems a little simpler, but oftentimes I find myself solving it slightly different, where I put the 2 out front to start with. So that would leave me with 2 times log base 7 of q to the 4th, r to the 2nd. And so then I would go through and say, okay, I see multiplication, so I'm going to turn it into addition. Now the problem is you have to remember it's now 2 log base 7 of that plus 2 log base 7 of r. So that's going to look like 2 log base 7 of q to the 4th plus 2 log base 7 of r squared. And then I'm going to get rid of those exponents. So the 4 is going to go times the 2, and 2 is going to go times the 2, which 4 times 2 gives me 8, and 2 times 2 gives me 4. So I end up with the same answer. Whichever method makes sense to you, choose that. But just make sure you don't lose any details, because what can happen here is oftentimes a student will say 2 log base 7 of q to the fourth, and they'll forget to put that 2 over here, and they'll just say log base 7 of r squared. So if it makes sense to distribute right away, go for it. So over here, I have log base 2 of y divided by z to the fifth, all to the second power. So you can choose whichever method makes sense to you. I'm going to go ahead and distribute to begin with. So that's going to give me log base 3 of y to the second z to the 10th, because I have y over z to the fifth 2 times. So that leaves me with 2 y's and 10 z's. All right, so what operation is happening? Well, I have division. What does that connect to? It connects to subtraction. So I've got log base 2 of y to the second minus log base 2 of z to the 10th. And then do I have any exponents that I need to get rid of? Yes, I do. So that 2 is going to come out front, and that 10 is going to come out front, leaving me with my answer. 2 times log base 2 of y minus 10 times log base 2 of z. All right, so for 31 and 32, we're going to rewrite them so that they look a little more familiar and they're a little bit more like the examples above. So log of the square root of 7x to the third. So we're going to rewrite that to the fraction power, because I think that's going to make more sense. So that can be rewritten as log of 7x to the third to the 1/2 power, because we're square rooting that whole value, and a square root is the same as raising something to a fractional power. And it's squared, so it's divided by 2. All right, from there, you can either choose to solve it like this and put that 1/2 out in the front, and then take the half of the log of 7 plus half of the log of x to the third, or you can distribute that half right now. Now, if you distribute that half right now, you're going to have to do some work with fractions, which is up to you. But remember that when we distributed it, we multiplied. So essentially, it's 7 to the first times that 1/2, and x to the third times that 1/2. So go ahead and choose whichever method you'd like and finish this problem out. Either way you approach it, you should end up with 1/2 log of 7 plus 3/2 log of x. So go back and look through. I solved it both ways and see which way makes sense to you so that you understand that. And finally, I'd like you to pause the video and try number 32 on your own. Alright, so for 32, hopefully you were able to find that the answer is 5 over 4 log base 3 of m plus 1/2 log base 3 of n. So I went ahead and solved it both ways, depending on your preferred method. We know that the fourth root is the same as something being raised to the fourth power. So over here, I distributed that fourth. So 1/4 times 5 is 5/4, and 1/4 times 2 is 2/4. And then I brought the exponent out front, so 5/4 log base 3 of m plus, because they're being multiplied, and 2/4 reduces to 1/2 log base 3 of n. Over here, I put the 1/4 out in front, so I did 1/4 log base 3 of m to the fifth plus 1/4 log base 3 of n squared, and then I moved those exponents out, and that gave me that same answer. Alright, so what are you going to need to remember about that process of expanding logs? So given one simple log and moving it to multiple logs, go ahead and write down any steps, any questions, any things you need to remember, your be sure to statements now. Alright guys, I know this was a lot. This was a really long video with a lot of information, but hopefully your algebra skills are helping you be strong in this. So I want you to look back and think about what are 3 common mistakes you think students tend to make. What is your summary of this topic? So what is this whole topic about the properties of logs? What are the things that are important? And then lastly, what is your comfort level? So are you a 0, completely lost, to a 3, you feel pretty solid in it?